This is a movie to demonstrate a simple model build using Witness Power with Ease. This is Microsoft Visio and this is the layout that we're going to use. So all we do in Microsoft Visio is export it into a WMF file. You then go to Witness using the basic startup, so you have your designer elements in, ready to go. So the first thing we'll do is import the layout. Now the layout here, as we saw earlier, was from Microsoft Visio, but it could easily be a DXF export layout. So we select it as an icon, draw it onto the screen, and then resize the screen so we can see what we're working on. So this is what we're going to have it start to look like. So the first thing we'll do is put some parts on. So we'll put a box and a carton onto the screen. Next thing, using more machines, we'll put a wrapping machine on the top left and then two counting machines. So that's the initial part. And using the visual input rules, we'll now take 60% of the box into the world, from the world into the model, and 40% of the carton. So it'll bring it in at a random amount, but using this percentage split. And then we want to push the box to the first count machine and the carton to the second count machine. And from that, the parts will then get sent to ship, so it'll just be they'll leave our model. So if we play the model, we'll put in just default cycle times for now, but we can see the parts moving across the screen, going to whichever machine they've been assigned to. And we'll do a quick 3D, so we'll have a look at, use the standard 3D base, and it draws our shapes, and you can just about see the boxes moving across the screen. We now want to insert a cycle time. Instead of just using a default of 1, we want to use a distribution. So using sort of the distributions wizard, we can insert, in this case, a negative exponential distribution with a mean of 5. So we don't have to type in code, it's all put in for us. And we're going to do the same for the two counting machines. Once you get more sort of used to Witness, you probably would just type the code in. But for starters, you'd use the wizard. We now want to have a path, because the lines connecting the wrapping and the counting machines, we want the part to actually move along that line as opposed to a straight line between the two. So using sort of the curved path box, we are just going to create two simple paths from the wrapping machine to each counting machine. So here we're specifying different segment sizes as we create the model. So changing it to 1. Now we'll put a curve in of a radius of 2 with an angle of 90 degrees, and so forth until we've created our first path. Having made the first path, we don't really want to create it all again, so we're just going to copy this one, so we'll clone it, and that'll do really with the first part we want to keep. The second part, where it goes down to the first counting machine, we don't want. So we'll remove those sections of path and add some new sections to go to the second counting machine. Right, we've got our paths, but nothing knows to use the paths. So we're going to edit our output rule from the wrapping machine, and we'll tell it to use a path. And we do that for both parts. But at the same time, we also need to define what the paths do, because at the moment they don't know where they're from or where they're to. So we're just going to define sort of the source, so where it starts, and the destination, so where the path ends. And we do it for both paths. So now if we look at the model, we can see the parts are moving down the paths between the two machines. If we open up 3D, we can see the paths are moving in the 3D space along the same path that was just defined in the 2D world. We now want to make our background display in 3D better. And what we can do is use this feature called carpets. And basically, our 2D picture, which is our process flow, we can define as what we call a carpet. And that is basically taken into the 3D world and used as a base for our 3D model. So now you can see we've got this. It could be the CAD layout, which would really enhance the 3D visualization of this model. The next thing we're going to do is add labour into our model. We want to use a pallet truck to move our parts from the wrapping machine to the counting machine. So just from Design of Elements, we've taken a trolley, and in addition to this, because we're going to put our trolley on the path, we need to have a path that moves the trolley from its idle position, its initial resting place, to join the path for the machine. So just quickly define the little path there that goes, as you can see, from the idle to the wrapping machine. Again, none of the machines know to use this trolley to push, because at the moment they're just pushing along a path. So we're going to go into the detail of the wrapping machine, into the output rule, and tell it to use the trolley now. So just add that bit of code in. And as with most Windows applications, you can copy and paste the text between the different parts. So once you've got the text you're happy with, you just copy and paste it around. So now we've basically slowed our system down because we've got a trolley that's causing our issues. So one thing later on would be to actually say, well, let's try 2 trolleys, three trolleys, see how that affects our output or utilisation of the machines, or whatever our key performance indicators are that we want to look at.